Okay, so now for REL6 Part 2. The second step is to identify translations. So in step 1, we identified the point h comma k. This is step 2, where we're identifying where the function has been shifted up or down. Let me put on my headset. Forgot to do that. Okay, so we're identifying where the function has been shifted up or down. So if the function has been translated, then h and k are the coordinates of the point h comma k. Now you might at first think, oh, that's a little redundant, right? Like, of course the coordinates of the point h comma k are h and k. But that's not what this is referring to. That's not what this is referring to. This h and k are the h and k that we put at the very top. This h and this k. Now it's important to note that this is x minus h and plus k. So just like with transformations, h is going to be backwards from what we think it is, but k is going to be a lot more like we think it is. So again, these h and k refer to the h and k in the equation at the very top, not the h and k of the point h comma k. But if there has been a translation, then h comma k does line up with h and k in the equation, which is why they use the same letter. So they are the same, but the reason why this is worded the way that it is because this h and this k refer to the h and k in the equation at the top. Okay, let's get started with the point h comma k. Actually, I should have highlighted that in purple. Doesn't really matter, but I've been doing the h comma k point in pink, so I want to use a separate color. Okay, so let's look at this first one. The h comma k point is right here. These are the same three examples as the ones above, so we know that this point is, from above, we know that this point is negative 4 comma positive 2. So that means that h is negative 4 and k is positive 2. That means that h is negative 4 and k is positive 2. Therefore, our equation is going to be, let's see, y equals, and I'm going to put parentheses here. So we have x minus h, so h is negative 4, so x minus negative 4. X minus negative 4 is going to give me x plus 4. Again, h is backwards, right? Because the equation is x minus h. So we have x minus negative 4. H is negative 4. X minus negative 4 gives me x plus 4. And this lines up with the transformations, right? Because transformations where you have x minus something sends the function to the right, and transformations where you have x plus something sends the function to the left. So we know that it's been shifted left 4, and this makes sense with what we've learned. K is plus 2, so we're going to add the plus 2 on the end. And remember, k is not backwards. There's a plus k in the equation, so we're going to keep that the same. Alright, and now we're not quite done, because the last part of the equation is this f here. Now f represents the equation of the parent. So in this particular case we're looking at a quadratic function. And so quadratic functions have something squared. The parent function is y equals x squared. So the plus 4 inside of the parentheses and the plus 2 on the end affect the equation y equals x squared. And so we're going to have y equals something squared with the following translations. Now for this one, we're looking at a cubic with the coordinates 4, negative 1 for the h, k point, which is at the point of inflection. Alright, so our equation is going to look like y equals something cubed. And we're going to have x minus h here. Now h is positive 4 this time, so we're going to have x minus 4. This is x minus h, and h is positive 4. K is negative 1. So we're going to keep that sign the same. Remember, h is backwards, but k is the same. And it's cubic, or it's cubed here, because this is a cubic function. The last one is square root. So we're going to put a point here at h, k, which is at the vertex of this sideways parabola. We know that's at 1, 1, because it's the same example as above. And the parent function for square root has a square root, so we're going to be transforming that. We have x minus h. H is positive 1, so we have x minus 1. And then plus k. K is also positive 1, so we've got plus 1. And that's how we write the equation of any of our 6 functions without having to do things like graphing using a table. Alright? This is a much faster and more reliable method of writing equations of functions. And it's almost complete. There is only one more piece that we're missing, and that's going to be in step 3.